All right, good morning. I hope you're doing well. So it's Tuesday. So I'm really sorry that it's taken me so long to get this Skittle Lab going. So what I'm going to do today is I'm going to walk you through how to do the Skittle Lab that's been posted on Google Classroom. It was posted like last Friday, Thursday or Friday. And I was hoping to get a video up by yesterday and I didn't get to it. So now I'm here. So we're here. We're going to do it now. This lab is helping us understand how old rocks are, okay, or how to determine the absolute age of a rock or of a fossil of something, okay? So what scientists use is they use this thing called carbon dating or radiocarbon dating, radiometric dating. They're all the same. They're all under the same hat. So what happens is we have these rocks and everything and fossils. They have all of these different minerals and substances within them. And a lot of times there's radioactive substances, and radioactive substances are very unstable. They're very they're very unhappy. They want to be happy. They want to be in control. And what happens is they break down, right? So they decay. And they usually decay into something else. Okay. So we have a radioactive substance. I'm just taking some notes and I'm going to show you here in a second. And it's called a parent substance, or we'll call them parent atoms today. Okay. So a radioactive substance, they're unstable. They want to be happy. Okay. So these parent atoms of this radioactive substance, they're kind of out of control, but they do something. They'll decay, they'll break down, and they'll actually get smaller and turn into a different substance. And that substance is called a daughter substance, or we'll say, and in this case, since we're looking at Skittle, we're going to say daughter atoms. Okay. So like I said, the parent atoms are really unstable. They break down and decay into daughter atoms, which are more stable. Now, scientists can use this. They can look at like a ratio of daughter atoms to parent atoms to see how old something is. So what this lab does is it kind of helps understand what parent atoms and daughter atoms are and how they kind of change. Okay. So I think the thing with this lab is that doing the lab and getting the data is very helpful for doing the lab, for helping understand it. So I'm going to just jump right in. Okay. I'm going to show you how it works. I'm not going to do the entire lab on the video because it does take a little bit of time, but I'll show you how it works. So if you can do it at home, then you can. You can do this. If you don't have Skittles, you can do it with M&Ms. You can do it. Can't do it with like coins, only because they don't work very well, and you kind of have to have a lot of them. So, but here, so what I'll show you is these are my Skittles. So these are going to be our parent atom, okay? Our parent atom in the lab, it's called skittleium, okay? That's the name of the radioactive substance. Skittleium's atoms are the ones that have the S, like they have the marking up here, okay? What's gonna happen is we'll roll these all out. If they land S side up, there'll be a skittleium atom. Okay, that's not a very good example, right? If they land S up, there'll be a skittleium atom. If they land the other way with no marking up, there'll be what's called a blankium atom. So skittleium is the parent atom, and they will eventually decay into blankium. Okay, so again, let's get the data. We'll work, I think probably we will Zoom to try and like work our way through this, but let's get the data first. So in here, the first thing to do is count all your Skittles. This is like your starting parent substance. And I counted, I have 188 skittleium atoms. Okay, so what I'm going to do now is I'm going to roll them out all into the table, trying not to lose them all. And what I'm going to do, so I have some that have landed S side up, so which are the skittleiums, and then I have some that have landed blank side up. And what I'm going to do is I'm just going to separate them into two piles. If they flip, and so if you're doing this at home, that's the first thing you should do. Okay. So while I am doing this, because I know this is really exciting watching me separate all of these parent substances decay into their daughter atoms, and we have something called a half-life. A half-life is the time it takes for half of a substance to decay into its daughter substance, or into, like, for the parent atoms to decay into daughter atoms. So if I have 188 Skittles here, what I should see is about, so if we have 188, we should see after one round or one half-life, we should see about half our Skittle side up and half our blank side up. So half of 188 is probably like 99, I think. I'm guessing off the top of my head. But we would want to see probably something, we want to see close to half and half, right? Half of them are Skittle side up, half of them are blank side up. So, and what we'll do is when we're done, I'll give you guys the class data, because everybody put their data together, and then we will graph it. Okay, ooh, that's an S. I'm trying to keep these separated. So these are my S's, these are my blanks. The first round when you do this takes a little bit of time, just because, I put those in the wrong pile, because there are so many, okay? If they flip on your way to moving the pile, that's totally okay. It's kind of like what they landed up as the first time. So getting close to 50-50 here, I think. It's gonna be close. Just trying to get all these S's over here. So again, it's kind of tedious, and I kind of feel bad that you're just sitting here watching me count these. But if this will help you do the lab at home, okay, then I'm gonna do 2 rounds here. So that way you can see how it goes each time. So that way, if you have the chance to do the lab at home, I'd really like you to, if you can. All right, so these are all my blanks. So what I'm going to do now, so here's my Skittleium pile, here's my Blankium pile. So these ones all landed blank side up, these ones all landed S side up. So I'm going to count these really quick. So we've got 4, 8, 12, 16, 4, 28, 32, 36, 40. 48, 52, 56, 60, 64, 68, 72, 76. So I've got 78 Skittleiums. Okay. So now let's check here. So this should be, so once I count all my Skittleiums, they go in this. So if I have 78 Skittleiums, that means I should have 110 blanks, because they should equal to what I started with, which is 188. Okay, so all my Skittleiums go in 1 cup. Okay, so then I would count these. Okay, I'm not going to spend another like 2 minutes just counting, but I know that I should have 110 because I started off with 188. Okay, so this should equal, right? So here's my data. It should equal 188. Okay, it's not quite 50-50, but it's kind of close, so that's okay. So once I do that, all my blanks go in another cup, and then we're done with them. The blanks, we don't touch them again. Okay, they've been decayed. The parent atom has decayed and changed into these. They're done. They're stable. They're happy. Now we do the same process again. So that was 1 half-life. Okay, now we have another half-life. We're gonna do the same process again, but now instead of having 188, I have 78. So I'm gonna do it one more time. Hopefully it goes quicker than last time, okay? So let's see, we're gonna start separating. I'm gonna count as I go. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 2, 4, 10. Let's see, 13, 14, 15, 16, 17, 18, 19, 20, 21, 24, 25, 26, 27, 28, 29, 30, 31, 31, 32, 33, 34. Looks like I've got, 35. Sometimes the lighter colors are a little hard to see. So I have 35 Skittleium atoms, okay? So I have 35. Now, I should have, so let's see, let's just double check. So my Skittleiums are gonna go back into this same cup, right? So I had 35. So just to do my math, that should mean, I'm a little slow with my math. So 3. So that means I should have 43 blanks here. Now, when I put them back in here though, I need to add this to here. So if I had 110 before and I have 43 now, I should have 153, right? Because it's the total between two cups. So this is always, so my number of Skittleiums are always going down because they're changing into blankiums. So this number should always be going up. Okay, so if you can do this lab at home, you're gonna continue until you have nothing left. Okay, so you're gonna keep going. Do the best you can. We'll Zoom tomorrow. I'll send you guys an email about Zooming and we will work through it together. All right, I hope you guys have a good day. Email me with any questions. Bye-bye.